Okay, so in this video we're going to cover abstract classes. This is the next 25 topic. If you've been watching my videos sequentially, you know I'm trying to go in order, but I decided to actually change my approach and just do what I'm learning now. So that way this benefits me and you, because like, one, you'll get this concept much faster, and you probably know stuff like string methods in the first 15 questions, right? But this might be new to you. And also, eventually then when I do cover it, I won't have to like relearn some stuff and I'll just be able to give you the full knowledge. So what's an abstract class? And this is gonna be based off of my object-oriented principles video. So this video would have gone over classes. So we talk about classes, if I can spell, inheritance, and then we talk about some key stuff like polymorphism. That's how you even say it, bro. In addition, we probably cover, or we did cover, let's say, yeah, overloading of both constructors and methods. And we've also would have covered overriding. So that's how much we should have so far. That's what I'm going to expect you to understand before coming to this video. So I'm not going to explain any of that. But, so what is an abstract class? So, an abstract class definition, or you might even see it referred to as an ABC, which is what I'll refer it as. An ABC is a class that cannot be initialized Okay, so this is the definition, a class that cannot be initialized. So, here I am in this blank main file. Let's, I have a lot of freaking classes. Let's just create a new class. I'm gonna call it my ABC. So my abstract class. And then right here, we're gonna write abstract. So this is the way you define an abstract class. You do public abstract class my ABC. Or conversely, you can write abstract public class my ABC. But that's it. Like you can't put abstract here because you get error. Nor can you put abstract here. You'll also get an error. So it has to be like before the class. So we'll write it. Let's, well, we're not going to do anything. So we're going to use the default constructor. So if I just do my ABC, ABC, I'll say my ABC is equal to new my ABC. I'll do that. Let's close this. I don't know why. I think it's, I have to have some keybind that tries to automatically do a lambda, bro. So let's say you wrote this, right? Well, now you're gonna see an error. Can I resolve symbol my ABC? Oh, shoot. My fault. I just wrote that wrong. Okay, so let's say you're creating your abstract class. Let's say we're gonna create my ABC. We equal to new my ABC, like this, right? Now I see we have a red squiggly. If you look at it, it says my ABC is abstract, cannot be initialized. So if I were to run this code right now, you'll see we're just going to get an error. The abstract class, or my ABC is abstract, which means it cannot be instantiated. Which I guess is the actual term. I said initialized, that's on me. But if Java says instantiated, then I'm going to say instantiated. Okay, so that's cool and all, but like, what does it even do? What's the specific thing that people use abstract class for, right? Because if it's not instantiable, then the only thing you could do is extend to make objects, right? Or you can extend for inheritance and have subclasses and stuff. So now I saw an example. The next concept in regards to ABCs I want to talk about and abstraction as a whole is the abstract method. So this is a method which no body that must be overridden by subclasses. Okay, so this is a definition of an abstract method. So let's create one for my ABC. I'll create a method, public abstract, my abstract method, parentheses, semicolon. Now you'll see, also we need a return type, I forgot that. So say it'll return void. Oh no, it's not to be here. My public abstract void, or public abstract void my abstract method. So you can view the syntax as your access modifier and your abstract keyword, and they're interchangeable. Then your return type, and then lastly your method name. So in this case, I'm calling it my abstract method, parentheses and a semicolon. So this is what I mean when I say it has no body. So we have the parentheses, but instead of normally having this like we would before, right, and you're writing some code here, we don't. We don't have any brackets. We just have a semicolon to end the line. In fact, you saw when we had some brackets, even though they were empty, we had an error saying abstract methods cannot have a body. Okay, now let's create a subclass, and I guess we can make it in a different file. New Java class, and I'll call it concrete class, because something that's concrete is like kind of the opposite of abstract. I think. I don't know if that's correct terminology or not, but that's what I'm going to call it. We're going to have it extends my ABC. The first thing I want you to notice is that abstract classes are extendable. So you can see that we can use them for inheritance, and we can have a real class that's not abstract extend an abstract class. Now I notice we're getting an error, and the error says class my concrete class must either be declared abstract or implement abstract method my abstract method. Now why are we getting that? Well, remember what we said in definition. An abstract method must be overwritten by subclasses. So we have the subclass, but we're not overriding it. So we have to implement that abstract method. And we have to override it. So now I can say successfully overridden or overrided? I don't know. Abstract classes are my ABC's abstract method. So if we go here now, what we can do is you can create an instance of my concrete class, and I'll call it my class object is equal to new my concrete class like this. Then we can do my class dot my abstract method because we made it public. And now if we run that, you see we will get successfully overridden my ABC's abstract method. So you can kind of view these abstract classes as a stricter parent. So it enforces the subclasses or controls them to have certain methods, right? All my subclasses must have this my abstract method. So you can kind of view it as a quote unquote template for a class. You can pretty much say, I want every class that extends IBC to have this method. And here you can create a few more. So my abstract forward 1, 2, 3, then I'll say this one will return a string. This one will return an int, right? You can say that we want every single subclass of MyABC to implement these three methods and override these three methods. It's a stricter parent and forces subclasses or controls them, forces them to have certain methods. See, look, now if we go over to back to our myConcrete class, we're getting that same error because we haven't overridden all of MyABC's abstract methods. So let's do that. So you can see we have this. I'll returning string. And this will be like my parent number is 8, so we're gonna return 8 here, right? And so there's a few more things I want to talk about with abstract classes. So this method is kind of has a edge case. So with the exception of an abstract subclass. So if I go over here and I create a new class, we're going to call it my abstract subclass. We're going to make it abstract, and then we're going to extend my ABC. Now you will see that Java is not requiring us to implement any of the abstract methods. We don't have to. We could if we wanted to, but we don't have to. We can actually even write some of our own. So we could do public abstract. And you know, what if we change it up? I want to show you can use any modifier here, right? Except for private. You can never have a private abstract method, as you can see here. So let's say I call this my private abstract method. Oh, that's cheating. And then we said return type void or something. We're still gonna get an error because illegal combinations of modifiers abstract and private. So why is that? Well, let's think about what the private keyword. Now let's write it here. Private abstract never together. So why? Well, what does abstract do? Abstract, in this case, that abstract keyword pretty much says subclass must override, right? For an abstract method. Well, the private keyword that we discussed specifies that subclasses can't override. So these two methods are contradicting each other. You can't have both. So, can you make a package private abstract method? Yes. Can you make a public abstract method? Yes. Can you make a protected abstract method? Yes. Can you make a private abstract method? No. But I'll just keep them all public. Right, so you can do this, and let's say we had a new class. My abstract, or my subclass. And this subclass is going to be public, and it's going to extend my abstract subclass. And the naming convention is starting to slip on me. Now you'll see that we have to implement not only my abstract subclass's methods, but all the methods in my ABC. These methods have to be implemented. If they're not implemented by this my abstract subclass, then the child of this class will have to implement it for it, as you can see here. Now, I'm saying how an abstract class could implement other methods. Now that might seem kind of counterintuitive because I've just talked about how abstract classes, or that might not make sense because I just talked about how abstract classes are pretty much abstract classes you can't instantiate and they have abstract methods. Well, that's not all. An abstract class can have abstract methods, but they can also have other things like a constructor or instance or instance slash static fields, and then you can even have concrete methods too. So you can see I'm highlighting red just so you can have both types of methods. So you can have abstract and concrete methods. So let's test this. Let's go to my ABC and right here. Let's test this with a real example to solidify everything. So I'm going to delete these classes. Delete anyways. Oh, how did my subclass survive the massacre, bro? I don't know. Wait, if I didn't delete that, then what did I delete? Undo deleting my ABC. No, I did delete them. I don't know. Okay, anyways. Let's create a new class. Let's call it animal. As an abstract class. So you want this class to define the general characteristics all animals should have. So we can create an let's say private field, let's say private int age. So all animals should have an age. String name. All animals should have a name, and we can have a private string species. So all animals should belong to a species. Now you can have a constructor animal that, let's just say, will take in an int age, a string name, and then a string species, and then we can just assign them. So this dot age equals age, this dot name equals name, this dot species equals species, right? Let's just do it in any class. Now I want to specify, even though we have a constructor in this abstract class, if I try to go to animal and say new animal equal to new animal 40 or 14, I don't know, like Fluffy, and he's a type of dog. You'll see, even though we have a constructor, we're still getting an error because you're not allowed to instantiate an abstract class. What this constructor used for is in subclasses. So subclasses would call super now. The subclasses are forced to call super. But you already knew this because you watched the object-oriented programming video. So, right, you can just do this, and then let's just say, okay, I want to create an abstract method that will return a void and be speak, because I believe that all animals speak a little bit differently. Public void, and I want to have all animals anger or roar. So I think all animals have a different type of, or what do all animals have? They have a fleeing method, right? Well, is that how it is in nature? All animals, you fight or flight. That's actually what we'll do. We have a fight, so all animals have a different fighting approach, and flight, so all animals have a different flight or fleeing approach. So these are two methods, and actually you're seeing an error now. If you're going to have an abstract method, even though this is an abstract class, you'll need to define the abstract keyword. Otherwise, Java won't accept it. And this is because we said in an abstract class, you can have normal concrete methods as well. So whenever you're making an abstract method, you have to use the abstract keyword for an abstract class. Lots of abstracts today. Let's create new. So let's create a dog, and then I'll also create a fish. These are going to be two instances, so we'll do extends animal, right? They're both types of animal. So here we can implement the methods fight or flight, and here we'll implement the methods as well. We're seeing we're still having this red underline because we have a constructor, so we need to create a constructor to match, just like this and just like this. Now let's say in dog, let's add a toString method at override, and we'll just do public void or public string toString, and this will return a string that's formatted. So this species called name is is 8 years old. And then here we will get the species, the name, and the age. I see we're getting these red underlines. This is because we have defined these variables as private. Well, let's see if we can use super to get them, right? Because normally if you want methods, or if you want variables from a parent class, you use super. Well, you see we're still getting these red errors because we defined the variables as private, which means they're only accessible to this class and subclasses cannot use them just by willy-nilly calling them. If I were to make this public name, now you would see this would work. However, actually this would work. I would still recommend doing super that name though. You know why this would work if you watch the group video. But yeah, let's turn this back to private. So I can see we have an issue. We want to use these fields, but we want to leave them private so we have good encapsulation methods, right? Good encapsulation philosophy. So what we need to do is create some getter and setter methods. Now in this case, let's say we only want getter methods. We don't really want them to be able to set these variables. So let's just generate some getters for all three. And here you can see some normal methods. We have some normal concrete methods in our abstract class. And so here we can go, instead of calling that, we can call get species. Here we will call get name. And here we will call get age, just like that. So yeah, you can see we're just calling all of these methods that we have defined. And so now, if we go to the fish class, let's just copy this structure, and we can pretty much copy this word for word. And now let's fill in some stuff for Firefly. The dog barks angrily, right? Fight. Dog whimpers and flees with its tail between its legs. I think that's an expression I hear people use. Fish. The fish angrily nibbles at you. Because fish are small, right? I guess unless it's a shark. Now let's do another print. Flight. The fish splashes away. Okay, so let's go back into here, and you'll see, let's delete this, and then let's create some instances. So we'll create a dog. I'll call him, let's say, Fluffers is equal to new dog, and he's gonna be 12. His name's gonna be Fluffers. He's gonna be the species. Let's say he's a poodle. I guess you would just do dog, but I don't know if you want to be specific. So let's print out Fluffers. And then conversely, let's do Fluffers.fight and Fluffers.flight. And then conversely, let's create a fish. And I'm gonna call him Swimming. sirSwimmington is tough. This new fish, he's gonna be, I don't know, how old? I'll say he's like 4. sirSwimmington. He's a type of goldfish. And then conversely, we'll call all the same methods on him. So what we might as well do is have a method, and I'll call it, I don't know, maybe it'll be like, I'll call it a display method. So we'll just do display, and we'll pass in Fluffers. We'll do display, and we'll pass in sirSwimmington. And then let's create a display method. So public static display, and it's going to be, oh, we need a return type, so it's going to be void. It's going to take in a type animal, because dog and fish extend from animals, so they're all animals. And then we can say, I want to do animal.fight, animal.flight, and then lastly I want to print out the animal. So we're just doing some polymorphism. So when we run this, you see we're going to get The dog barks angrily, the dog whimpers and flees with his tail between its legs. The poodle called Fluffers is 12 years old. The fish angrily nibbles at you, the fish splashes away. The goldfish called sirSwimmington is 4 years old. You can see the polymorphism in action. And yeah, let's do one more thing. Let's say we have a class mammal. It is an abstract class and it extends animal. And then let's say that we're gonna, why are we erroring? I think we have to, yes, we have to pass in the constructor, because even though you don't have to pass in that abstract methods, there's still a normal class, so inheritance rules still apply, so you still have to do this constructor, right? And then we're gonna create our own public abstract. And for this case, we can even make it protected, because we want only mammals to be able to do this, right? So maybe over here we can make all of these protected too. Let's just signify that only subclasses of animal, along with any other class in the package, can use these methods. Let's create a protected abstract method called shed, because mammals have hair, so they need a shed. And this will be return void. And then so here when we look at dog, instead of extending animal, we shall extend mammal. And then let's say we didn't have these methods, so I'll just copy them out for a second. So you'll see when I hit implement methods, I have to implement the mammals and the animals methods. So here I can implement them all, and well, we already have stuff for this, so I'll just print it out like this. And then here I'll just say the dog sheds hair. So now if we go over here, we can say if animal instance of, how do you say, instance of mammal, then I want to do a mammal. I want to make an add, say current mammal. Or actually, I think we can just do this. I think I'm trying to do pattern matching. And we can do currentMammal.shed. This is an example of pattern matching. What we're basically saying is if the animal is, well, you know instance of, but you might not know this bit. So I'm saying if animal is a mammal, then essentially we're going to create a mammal object called currentMammal, and then we're going to call shed. Because if we try to run this and we try to say animal.shed, well, we're going to get an error because shed does not exist on type animal. Remember that the declared type, this dog, this fish, this animal over here, corresponds to what methods we can call. So because animal doesn't have a shed method, we cannot call it, which is why we use this pattern matching to make a variable that has a declared type of mammal so that we may call shed. So now when I run this, you'll see that the dog will shed his hair, but the fish won't shed anything because it doesn't have a shed method. Okay, let's look at my abstract classes. So one thing I didn't discuss, but actually we kind of did here, you can also make these animals too if you wanted to. That's also fine. I'm just doing it like this. So in case I don't have any, but in case dog had any custom methods, we'd have access to it. We talked about this, we talked about that, we talked about that. Okay, we're looking good on abstract classes. Okay. Thank you for watching this video on abstract classes. We covered a lot of important ground today, and I hope that you understand what they are now. I hope these examples helped, these definitions helped. I will probably put this stuff in the description, along with the code from today and also in the description, unless I forget.